According to Mendeleev, the main player in the periodicity of elements was considered as the atomic weights of the elements. In 1914, however, a British scientist, Henry Moseley, came up with some fabulous results with his X-ray spectroscopy of elements and found a relationship between the X-ray wavelength and atomic number. He suggested that periodicity in elements is not a function of the atomic weights, but a function of the atomic number of the elements. By this time, it was proved that atomic number is not merely a sequential identity of elements, but the atomic number actually represented the amount of positive charge, or more specifically, the number of protons in a single atom of the element. Moseley's research filled up many gaps in the periodic table. For example, positions 43 and 61 were filled up by radioactive elements technetium and promethium respectively. An American scientist named Glenn T. Seaborg then discovered the transuranium elements. This contributed to the isolation of 10 elements and the development of the actinide series. All these discoveries led to the establishment of the modern-day periodic table, which is like this. In the Mendeleev's table, the groups were named like this. After recommendation from the UPAC, they were numbered from 1 to 18. Some groups were called by names. Group 1 was called alkali metals, Group 2 was called alkaline earth metals, Group 3 to 12 were called transition metals, Group 15 was called pnictogens, Group 16 was called chalcogens, Group 17 was called halogens, and Group 18 was called noble gases. The inner transition metals or rare earth elements lie over here. The first row was called lanthanide series and the second row was called actinide series. There were 7 rows called periods. We know that the principal quantum number n defines the main energy level, which is known as shell. The period actually indicates the value of n of the outermost shell of that particular row. We also know that the subsidiary quantum number L denotes the subshells and is represented by S, P, D, F, etc. The periodic table can also be grouped into different rectangular blocks where a particular subshell is being occupied by electrons. This is the S block, the P block is over here, here's the D block, and the F block is at the bottom over here. The S and P block elements have vertical similarity, whereas the D and F block have more pronounced horizontal similarity than vertical similarity. You see that hydrogen is not studied under the S block because chemically and physically it differs a lot, and also some sort of similarity with halogens in the way that it completes its outer shell by gaining 1 electron only. Helium is studied under the P block, although logically it should have been an S block element. But the fact that it had similarity with the other noble gases of having completely filled outer shell, it was kept above neon in the P block. All the 118 elements shown here have been discovered or reportedly synthesized. However, the elements 113, 115, 117 and 118 have yet not been confirmed. The first 98 elements are naturally occurring. Out of these 98 elements, these 84 elements are primordial and the rest of the 14 elements are found in trace amounts in primordial radioactive elements as a result of radioactive decay, which were initially synthesized in laboratories. The rest have been synthesized or claimed to be so. About 78% of the elements in the periodic table are metals. See this zigzag line over here. The elements that fall just right to this zigzag line have both metallic and non-metallic characters and are called metalloids or semi-metals. The rest are non-metals. The metals normally have high melting and boiling points. There are, however, 3 exceptions: mercury, gallium, and cesium. In fact, mercury is a liquid at room temperature. The non-metals normally have low melting and boiling points. Boron and carbon is an exception. Out of the non-metals, these are gases, this is a liquid, and the rest are solids. In a particular group, the metallic character increases down the group because obviously the outer electrons get to be more and more mobile due to increasing distance from the nucleus.